Okay, so let's talk about chemistry and some of the more basic terms. To start off, let's talk about states of matter. And the states of matter, well, at least the ones we're going to talk about today, are going to be solid, liquid, and gas. So things you should be very familiar with. So a solid, the difference between all of these states is the arrangement of atoms and their energy, so how excited the atoms are. So we can rank them from lowest energy to highest energy. So the highest energy of the three is going to be gas. Lowest is going to be solid. And in the middle is going to be liquid. So in a solid, what you're going to see is that the atoms or the molecules are going to be tightly packed. And they still move around a little bit, so there's still going to be some motion. But it's not very noticeable, and the atoms tend to stay where they are. In a liquid, things get a little more energetic, and you still have atoms that tend to stay near each other, but they can start sliding past each other. And then in a gas, the atoms or molecules are just off on their own, going wherever. And then we can define them by certain characteristics. So a solid has a defined volume. In this case, defined means a constant volume, so its volume is not going to change if it keeps being a solid. And it also has a defined shape. So if you put a solid somewhere, it's not going to change shape. Now a liquid is going to have defined volume, but it's going to have undefined shape. So you can think about it as when you pour water into a cup, it turns into the shape that fits in the cup. It doesn't stay in the same block it was. And for gas, it's undefined volume. So a gas tends to spread out as far as it can, and undefined shape. Now with that out of the way, we can also tackle something else. So substances and mixtures. So what a substance really is it is a chemical compound. Oh, sorry. What a compound is it's a chemical substance made up of two or more types of atoms. Now, it's really important to understand what types means. So by that it means two or more elements, so atoms that differ in their atomic number. And this is really important because you can have things like nitrogen gas, so N2. It's not a compound because it's not two or more types, it's two or more atoms that are of the same type. But it's a molecule. And a molecule is just a substance made up of two or more atoms. So it's important to know that all compounds are molecules, but not all molecules are compounds. And as for mixtures, these are unbonded combinations. So think about it as, say, you can put sugar and flour. So you dump the two together and it makes a big pile. But you can still inspect it and pull out 1 grain of sugar at a time. So the two aren't chemically bonded. So that's a mixture. And then we can also talk about a solution. So a solution means something that is dissolved in a liquid. And you can think about it as this. So you can put salt, and you put it in water, and well, if you put a salt cube in, as time goes by, you're not going to see the salt cube stay in its form. It's going to get dissolved. So what that means is that the atoms in the salt are separating into, well, if this is table salt, so NaCl, it's going to separate into Na and Cl ions. But also, it's very important to understand that this is not a chemical change. Even though they're separated, the salt still retains its properties. So if you drink salt water, it's still going to taste salty, even though it's not going to be one big block of salt that's in there. And then now we can talk about metals, nonmetals, and metalloids, which are the three classifications of elements. And there's distinct characteristics. So we have the state, so the state of matter, that they tend to be at room temperature. We have their electrical conductivity, so how well they can transfer electricity. Heat conductivity, so how well they transfer heat. Luster, which is just shininess. Malleable, which means how much you can shape the material without breaking it. And ductile means if you can turn it into a wire. So first of all, we have metals. Now, metals tend to be solid with one exception, which is going to be mercury. Mercury tends to be in liquid at room temperature. Metals are quite conductive, so yes, they are conductive, and that makes sense because most of your wires are going to be metals, normally copper, with the exception of fiber optics. Heat, yes, metals are conductive when in regards to heat. Luster, yeah, metals tend to be shiny, so shiny. Malleable, yes. And ductile, yes, because as we said prior, a lot of wires are made of metal, so we know that it's ductile. And now we go on to nonmetals. So nonmetals can be a variety of states. So we have gases and solids and one liquid, and that's going to be bromine, which is a liquid at room temperature. Nonmetals tend to not be electrically conductive, and that should be quite obvious when the air doesn't just spark normally. That would be very bad for living things like us. They're also not as great at heat conductivity as, say, metals, so not really conductive to heat. And quite obviously, I hope this is obvious, it's not shiny. It would be very weird if the air is shiny. And nonmetals, if they are solid, tend to be not malleable. They tend to be very brittle. So when you try to shape them, they tend to shatter a lot. And as such, they're not ductile. And metalloids, they're very interesting. They tend to be solids at room temperature. They sometimes conduct electricity. They are not great conductors of heat. They can be both shiny or dull, so can be both. And in terms of malleability, they are not. So they can be brittle, and as such, they're not ductile. And the interesting thing about metalloids, this is one of them, this is silicon. They are very interesting for us humans because of this property, their electrical conductivity, the fact that they can sometimes conduct electricity under certain circumstances. And that allows us to make things called semiconductors. Now, if you are watching this video, you are using a semiconductor. That is how your computing device is working. So that makes these metalloids very important to us. Now, these non-metals, metalloids tend to be located in certain places on the periodic table. So let me pull up an image. Metals tend to be located on the left side of the periodic table, so metals tend to be over here. And then typically here, there's a cutoff. So typically metals end here. And this range, don't take this with a grain of salt because there's a lot of dispute over exactly which elements are metalloids, but silicon is always a safe bet for metalloids. And then say this part should be nonmetals. And this typically holds true with one major exception, hydrogen right here. So hydrogen is a nonmetal. So it's important to remember that metals tend to be on the left side with the exception of hydrogen. And that should be enough for you to establish a basic understanding of chemistry. As usual, this is not comprehensive. It's always important to go more in depth on your own, but I hope this helps.